Good evening, everyone.
Good
Welcome,
evening.
Professor Waki, sir.
Good evening, sir.
Good evening,
Thank
sir.
you.
Well done, sir.
Good evening.
Good
Thank
evening,
Okay.
you.
sir.
Good evening. Thank you. Yeah,
Good evening, sir.
good evening. So we'll
Yes,
start
sir.
our discussion on probability distribution. The last lecture, we gave in the introduction about probability. Introduction to probability, we talk about many things. But now let's discuss probability distribution. You'll be surprised that the word distribution is common in statistics. You remember when we started discussing descriptive statistics, the first concept we discussed was distribution, where we talk about frequency distribution, relative frequency distribution, cumulative frequency distribution, and cumulative relative frequency distribution. Now, we are talking about probability distribution. Now, very soon, we'll still talk about another type of distribution. But in another, it looks as if it's another time. It's not actually another, it's the same thing in a different way, perspective. So even this distribution we are looking at as probability distribution, is the same thing as the distribution we have been talking about, especially relative frequency distribution in another way. And you remember the frequency approach also, we talk about it when we talk about the approach to probability. Now, distribution, probability distribution is the distribution that shows the probabilities of all possible values of this random variable. No, remember when we first of all talk about distribution, we said the pattern of occurrence of value of a variable in a data set. That is, if you give example, I use the parity the parity of group of women to illustrate that. It's the same thing here. Distribution that show the probability of all possible value of a random variable. For example, now, sex is a random variable. The meaning of random here means it can take any possible outcome, any possible value. So sex, male is possible. Sex, female is possible. So it can be anybody. Since is not constant. If you are studying women, maybe women that go to antenatal, sex is not a variable, it's a constant because all of them, if you ask, they are female. But in the situation that in this class now, some people will be male, some will be female. So in that situation, sex is a variable. And the distribution, probability distribution here is what are all the possible value of sex, whether male or female. So what proportion is male, what proportion female? The proportion of the member will express as decimal or percentage. That's the probability. So the percentage of male and female. So when you know male and female and you put their percentage, that's probability distribution. So when you do your study, you collect data, you say tabulate sex, say male 40%. Give the value, you say 40%. Female, you put the value over total, say 60%. That is probability distribution. And now it's distribution that show the probabilities of all possible value of a random variable. If maybe we'll talk about any ethnicity, in Nigeria, we usually say Hausa, Igbo, Yoruba. So in that situation, indeed, maybe you have 800 as sample size. How many are Hausa? How many are Igbo? How many are Yoruba? How many are others? And everything add up to 100%. So you are put there's relative frequency, which is the percentage, is the probability. That is, if you do that maybe in Abuja now. So if somebody say, what's probability? I just pick somebody at random, the person will be Igbo. If from the previous one you have already tabulated and say, okay, this is the population and this is the number of people, you know the percentage. That is the probability that whosoever I pick is an Igbo person. Whosoever I pick is an Hausa person. Can you see now? So the probability is just like what you do when you try to tabulate your results. Now, let's discuss further. Random variable, as I've said before, quantity that can take one of a set of mutually exclusive value with a given probability. So the example I've given, the two examples, they have explained the concept. So the probability distribution is a theoretical distribution. So when you say something is theoretical, don't be deceived. It was practical before. When you do practical over, you now find the same result. So people don't need to bother because it now become theoretical. As it just theory, this is how it is. It's just like when you say 2 + 2 is equal to 4. It has been proven over and over that 2 + 2 is equal to 4. People have tried to do, and it become so you don't just tell you 2 + 2 is equal to 4. Look at law of this gravitational law. Before, it has been tested over and over since the time Newton observed it. They have done an experiment to test it, validate it over and over. It was an hypothesis to the man, Newton. Later, it became theory. Later, it became principle. Later, it became law. When you do a theory, you test it consistently through, it becomes principle. Over a period of time, you cannot refuse it, it becomes law. So the same thing here, when they say something is theoretical, it has been proven over and over, and now, so when it was being proven, it's practical now. But when it has been proven, just take it like that. That's why they call it theoretical distribution. You want to know much about it because the normal distribution, which is the most popular distribution in statistics and research, is the basis for hypothesis testing, and is the most popular distribution in statistics and research, followed by binomial distribution. So they have become theoretical distribution because they have been proven over and over and found to be true. So probability distribution is a theoretical distribution that is expressed in the tabular form, graphical, or mathematical. So statistics is about modeling life situation. When you model it, you can summarize it on a table. Imagine now, somebody you take, as I've said now, you take ethnicity, you measure people's weight, and you do your research, you begin to tabulate the result. What you are summarizing that true life situation in a tabular form, or you can use graphical form, or can use mathematical form. So in statistics, when you are tabulating, you are showing distribution, it's actually probability distribution you are showing. It's probability distribution. So can you see how probability and statistics are intertwined? You cannot separate one from the other. Now, you either express in a tabular form, or graphically, or mathematically. Those are the three ways. But the commonest one that people get to understand is tabular and graphical. Though graphical give, it's a picture 6,000 words. It's easy for people to conceptualize, but many times in academics, people don't want too much graph, because too much graph, you won't be able to put in the statistic to explain it there. Then when you put table, you'll be able to accommodate the statistic that explain those relationships we are looking at. So that's why when you are presenting in academic circle, more of table, less of graph. They can still show some graph. But if it is development work, where people ministry, everything can be graph. It's just okay, this one is taller than it, that's all they want to know. But in academic world, they want to know some deep things. And you can only get this deep interpretation by including some statistics, which most of the time it's not easy to include when you plot graph. But when you tabulate, you can. So it's either you use tabular form, or graphical, or mathematical. Each probability distribution is defined by certain parameters that characterize the distribution. Now, let's now look at two types of this distribution. Okay, let's first look at the two important characteristics of probability distribution. This one is the first two rules in probability we have talked about the last time. The probability of a particular outcome must always be between 0 and 1. We have already know that's rule 1. Probability cannot be less than 0. It cannot have minus 2, -1. No. It cannot be greater than 1. You cannot have anything greater than 1. You cannot have 1 point anything. Apart from 1.0, cannot be 1.1, cannot be 2, cannot be 3. So probability is between 0 and 1, inclusive. course, it doesn't mean that the probability will be between 0. It can be any value between 0 and 1 inclusive as rule 1. Rule 2, the sum of the probabilities of all mutually exclusive. So is it non-due? You have to mute.
Thank you.
Yeah. So the sum of the probability of all mutually exclusive outcome is 1. For example, I like using the simplest one before you go to the complex. For example, this issue of yes or no, male or female. If you say, okay, what is the probability of if I pick somebody, it's a female, you say 70%, 0.7. So automatically, if a male will be 30%, 0.3. Because 2 of them will add up to 1. Because those are the 2 possible values of that random variable, either male or female. What's the probability of male? When you add it to the probability of female, it should give you 1. If you leave the ethnicity, as I said, that's why Igbo Yoruba about that. When you put all their probability, it should add up to 1 or 100%. Because they are mutually exclusive. If they are mutually exclusive, we already, all those 2 examples have given they are mutually exclusive in the sense that you cannot be male and female at the same time. You cannot be a Hausa and say you are claiming, but you must claim one at a time. So the same thing, many, have you heard of yes or no? It's either yes or no. If you say yes, you cannot say no. Even if you say yes or no, I don't know, at least the 3 of them. If you say, does tuberculosis cause weight loss? Say yes, say no, I don't know. There are 3 possible values there. So when you add all the probability together, it will give you 100%. Wow. Because those 3 are mutually exclusive. Now, let's look at the 2 types of probability distribution. This probability distribution we talk about, there are 2 types. They are categorized into 2. The first one is discrete probability distribution. Then they have discrete, then the other one is continuous probability distribution. For discrete probability distribution, the probability distribution is a type in which we can derive probabilities corresponding to every value of a random variable, every possible value, rather. For example, male and female, all the possible value is male and female. Even if you say we have hermaphrodite, let's say we even have hermaphrodite, that's another 3rd one. So you don't have more than that. So you can derive, you can say, oh, what is the probability? We can calculate the probability of male and female and hermaphrodite. That is why it's discrete probability distribution. And the reason is very simple, because they are mutually exclusive. And now we have another one, continuous probability distribution. The probability distribution in which we cannot derive probability corresponding to every possible value of the random variable. It is not possible to know all the possible values because they are infinite. So let's use the best way to explain this here is the classical approach. You remember the definition of classical approach. Number of outcomes favorable to the event over total number of possible outcomes. If we use it for male now, if they say, what is the probability that I pick somebody is a male? All you need to know is that the event is I pick somebody is a male. That is the event. So how many are male in the class? That's the number of possible number of outcomes favorable to the event. The number of people that are male, and if I pick, the event is I pick a male. So the number of male in that class will be the number of outcomes. The number of outcomes favorable to that event be a male. Then the total number of possible outcomes is all the possible outcomes, either male or female. So that's why we talk about proportion, part of a whole. So the male divided by the female, the total male and female together. So you can see you have numerator and denominator. Now, for continuous probability distribution, you may even have numerator, you cannot know the denominator. That's where the problem is. For example, now if I say blood sugar, somebody has blood sugar of 60 milligram %. Now, that 60 you have. If you, okay, how many have 50 in the class? What's the probability of somebody have blood sugar of 50 or 60? You may say in your sample size, you see about 40 people, they have blood sugar of 60. That's one. How many possible blood sugar? Because how many possible possible value of blood sugar is infinite. Is infinite because blood sugar is continuous variable. You cannot say we have only 31 possible value. No. In between 60 and 61, you can have 60.11, 60.02, 60. Any, in fact, infinite number. So because of that, the number of, if you look at the discrete probability distribution, the number of possible outcomes we know. But for the continuous probability distribution, for continuous variable, you don't know the number of possible outcomes. They are infinite. So the number of possible outcomes is infinite. But for the discrete, you can know. That is why you can easily know all the possible outcomes and calculate their probability in discrete distribution for discrete variable. While for continuous variable, which follow continuous probability distribution, it is impossible to know all the number of possible outcomes. Can you see? However, even though you cannot tell what is the probability of a given value, you can say what is the probability of a range of value. We'll get there. We'll get there, you see. You can say what is the probability that somebody has blood sugar between 60 and 72. You know, how many people have blood sugar below 60, above 60, between this and this, below this, above this, are range of value. You can know that, but you cannot know how many have blood sugar. You give a particular point value. It's not possible. So you see, now the continuous probability distribution. Here, I wanted to be most of the time. I actually explain. Maybe I should just move quickly to first of all look at discrete probability distribution. I'll come back to that continuous probability distribution. Before, I usually take the discrete first, later continuous. But in one of my lectures, I rearrange it. But later, I feel that let's talk about discrete first. And the reason I changed it there, I thought maybe because I like something that will be simpler first for you to get the understanding before you go to the complex one. But later also, I still discover that is it not better we talk about discrete and leave it because the normal continuous probability distribution, that's where normal distribution belongs, and that is the basis of hypothesis testing. So discrete probability distribution in which you can know all the number of possible outcomes and calculate their probability. There are examples. We have binomial distribution, geometry, Poisson, hypergeometry, multinomial, negative binomial. We'll just explain one, which is binomial. And the binomial is the second most popular distribution in statistics and research after normal distribution. So the binomial distribution, which is the second most important, the most popular, is the most popular among the discrete probability distribution. So the continuous probability distribution, normal distribution is the most popular in continuous probability distribution and is the most popular in statistics and research. This shows the probability, the binomial probability is very simple. It's just that when we classify variable, we say we have nominal, ordinal. Under that nominal, whenever there are only two possible outcomes, it's binomial. Bi means two, or dichotomous variable. A variable that there are only two possible outcomes, yes or no, alive or dead, female and male. No pass, fail. If there are only possible outcomes, that particular thing follow binomial distribution. So this shows the probability of every possible number of sources in an experiment in which there are only two possible outcomes. A trial, sources of failure. The binomial distribution has this characteristic. Don't mind all this grammar. That's why sometimes if the mathematician or statistician or teach you all those things, you'll be lost because they just use What all those show the probability of every possible number of successes is the issue is that there are two possible outcomes. Per time, you may be interested in one, and that one will be the success. For example, now if somebody is interested in, if I choose people, what's the probability I choose female? If female is what the person put forward. So female is success, male failure. But if it is male, the person put forward, what's the probability that I choose a male? Choosing a male will be success, female will be failure. If the outcome is yes or no, if you are interested in the yes is a success, the no is a failure. But if you are interested in the no is success, the yes is failure. So it's the two possible outcomes, they say success or failure. That is either head or tail. As it may be success head, then failure tail. That is when you choose there are two possible. You are trying to differentiate the two of them, either success. So it shows the probability of every possible number of success in an experiment. So if I toss the coin now, if it is, there are two possible outcomes now. But if I'm interested in the head, now if I now toss coin 50 times now, how many times do I have that head? That's the number of success. That's the way it works. But it accounts for the other one. It's just like when we say, I choose somebody. Oh, the probability, the percentage value of female among the class is 70%. Somebody will now ask you, and what of that of male? You begin to say, what's wrong with this person? Because if female is 70%, the remaining 30% will be male, So it gives room for that. Look at the way we express it mathematically. Probability of R, which R here is number of observed success. Can you see? D is equal to N. Here is number of trial. How many times that is your sample size. When you go to the field, your sample size is 400 people. You know that for your questionnaire, each of the variable there, you ask from all those 400 people. So for each of the variable, you perform the experiment, you do 400 trial. That's your sample size. It's like tossing coin 100 times or 400 times, 400 trial, 50 times, 50 trial. So N is the sample size or the number of trial. Or in examination now, where you know that the person you give option, MCQ, and you know that the person will ever be wrong or right, irrespective of, either they give true or false or A, B, C, D or A, B, C, D, E. One answer is correct there. There's one you are going to choose. If you can choose that one, that's success. Choose anything outside that is failure. Then the number of questions, if it's 50 questions, that's the number of trial. So can you see now the way it works? So R probability R, which is number of success, over is equal to N factorial. Factorial means I say 5 factorial. It means 5 times 4 times 3 times 2 times 1. If it is 7 factorial, it means 7 times 6 times 5 times 4 times 3 times 2 times 1. Can you see that? So you understand the meaning of factorial. Now, N factorial is over R factorial. That is the number of success into N minus R. So the N minus R will be number of failure. Can you see now? If N, you have 50 trial, and we have 30 that is success. So the remaining 20 will be failure, which is N minus R. Can you see factorial? So R factorial multiplied by, we can say success factorial multiplied by failure factorial. Because that failure is the N minus R times P. This P, which is probability of success in each trial, raised to power the number of success. Q is the probability of failure, which you can get it from 1 minus P. If somebody of success is 30%, failure will be 70%, 0.7. Can you see now? So Q, probability of failure, raised to power the number of failure. Can you see now? It's very just simple. So it's not a big deal. And it will give you a probability. And the graph you are seeing here is just the distribution. That if you make many time, so you calculate it for each. So if you do it in many scenarios, you plot the graph, you see that depending on the sample size, the graph will begin to look. If the sample size increases, the graph begin to look like normal distribution. Look at this blue one. That dot the blue graph here is when probability is 50%, 0.5, and sample size is 20. Green is when probability is 0.7, the probability of success, P. Probability of success is 0.7 and sample size 20. The other one is red is when probability of success is 0.5 and sample size 40. Can you see now? As the sample size increases, this graph begin to approximate, look like normal distribution. We'll still talk about that when you get to introduction to inferential statistics. When we finish lecture on probability, introduction to inferential statistics, we'll talk about those. So be understanding bit by bit, you get to understand. So that is what I want to discuss. Only one I want to discuss. There's no need. So as you are getting to know it more and more, some of this other one, Poisson distribution, hypergeometric, all those ones you get to know. Now, let me tell you something. Every categorical variable followed binomial. Every. If you know the logic, we already said that, okay, if the nominal categorical variable nominal is 2, we say binomial. Even if it is 5, you can say, okay, for example, now, when we say Hausa, Igbo, Yoruba, other 4 categories, we may say Hausa compare with others, proportion of Hausa compare with others. In that situation, Hausa will be success, the other will be failure. Then you may say Igbo compare with other, Igbo is success, the other failure. Or Yoruba compare with other, Yoruba is success, other failure. Can you see the way it works? So you can actually collapse. You can choose one and compare with the rest. In that situation, you turn into binomial. So that is why actually anything categorical follow somehow you can follow binomial distribution. It's a matter of collapsing a lot of group. So you collapse the group to 2 possible values. One group may compare with other. So we still follow binomial distribution. Let's come back to normal distribution. That's where we want us to, because a lot of things I want you to learn there from this normal. So under the continuous probability distribution, we have normal distribution, chi-square distribution, T distribution, F distribution, and exponential distribution. We talk about normal distribution here. But of course, as we discuss statistics, we will not talk about chi-square distribution. We go to T distribution, F distribution. So even the exponential, that will follow logarithmic distribution. So now, let's look at normal distribution. You've seen graph like this, it says normal distribution. It's bell-shaped. It's bilaterally symmetrical. Now, how do they plot this type of graph? See, I wanted to put illustration. How do they plot this type of graph? What they just plot is that if you look at the vertical axis, is frequency, number in each case. So horizontal is X, is the value. For example, now, the easiest one to explain is, let's say, weight of adult, not children, of adult. You imagine you put weight along the horizontal, all these 40 kilogram, 45 kilogram, 50, 65, 70, 75, 80, 85, you mark it along the horizontal. And the vertical, maybe what percentage of your distance is that the frequency. Let's use relative. You either use relative frequency or just the raw frequency. How many? What is the frequency now? How many times do they appear? Let them even use the frequency. How many times? How many of them? Maybe in among 100 people or 400 people. How many of them? That in each that has each value. That is the F, which is the vertical axis. So you see, if you move, as you are moving, let's say here at this point, let me use annotation. At this point here, maybe we say 40 kg, because few adults measure weigh 40 kg, and this is 45, 50 kg, 55, 60 kg, 65. You now have 70 kg. Let's say you now have 75, 80 kg, 85, 90 kg, 95, like that. So for each this 40 now, how many in that your sample have 40? Maybe there is only one. There's no one, because it's rare for adult to weigh 40. Maybe it's one. That's right. How many are weigh 45? It may be 3, because it will be more. You have more people that weigh 45 than 40. So maybe the frequency is going up. That's because where the frequency meets with the value of the weight is what you see the graph trace now. So here now, so for 50, how many? Maybe more people weigh 50 than 45. More people weigh 55 than 50. More people weigh 60. No, that's why it's going up like that. More people weigh 65 than, then more people weigh 70 than 65. But as you go beyond something like 70 kg, when come to adult weight, less people will weigh 75 than 70. Less people will weigh 80 than 75. Less people will weigh 19 than 95, 85. Less people will weigh 90, less people will weigh 95 than 90. Less people will weigh 100 than 95. Can you see now? So the way, so you see most variable, most variable, biological or social science variable, naturally occurring variable, they follow this pattern. As the value of that variable increases, the number in the population that has the value increases until it reaches a particular value. As the value increases further, the number of people that have a value begin to decrease also. So the way it goes up, it comes down. So when you plot the graph is symmetrical. That is symmetrical, means that if you divide it in the middle, one side is the mirror image of the other. That's what we call bilaterally symmetrical. And it's bell shaped. It's like a bell. Now, this is what we call normal distribution. So I think the word normal comes because that's what many variables, naturally occurring variables, behave like that. And that's it. This is a normal distribution. That's where the name normal distribution comes. So there's nothing normal about it anyway, apart from that. Now, the problem you have with, yes, we know that is bell shape, is bilaterally symmetrical, but there's some problem you have with it. There's some limitation. Now, so yes, I have to erase all these. Let me share, stop sharing and reshare, so that all those marks I put there. Yeah. So look at this. This graph is the same graph, but we have two graphs that are normally distributed. You see that both of them they overlap these two graphs. Both of them are bell shaped. They are bilaterally symmetrical. They are normal distribution. They are normally distributed. But it's not actually the same shape as per the way the bulginess of the two graphs differ. And the reason is very simple. Different variables have different scale you use to measure it. Like when we're measuring weight now, we'll be talking about kilogram, and the kilogram for woman will be talking of 60 something, 80 something, 70 something. But if it is height, we'll be saying in centimeter, 152, 167, 183, 170, 150, 160, or even measure in centimeter. But if we measure the height in meter, 1.72, 1 point. Can you see? If you are talking of a distance traveled by a car, with 1,500 kilometers. If it's a plane now, you can say 2,000 something kilometers. So if you are talk about, if you are talking about blood sugar, you have different value as per when you say kg and when you say milligram percent. If you are talking about concentration, if you are talking of blood pressure, you have a value maybe in milliliter of mercury, but their value is not the same. You see, when you are plotting, they will not, because it's not standard. They don't have the same value. That is why when you are plotting physics, when you want to plot graph, you have to state your scale. See, 1 centimeter represents 1 unit, 2 centimeter represents 10 units, depending. For both y-axis and x-axis, you must state your scale. So because of the different scale of measurement, a different scale for different quantity of variables, even those variables that follow normal distribution, when you plot yourself, the height of the graph may be different depending on the scale you choose. But what we are now talking about the bulginess, and that bulginess has something to do with the behavior, the way the variables spread. For example, now height spread more. Weight spread more than height in the population, because weight differ among people more than the way height differ. People's height, you bring all together now, there's no much difference in our height. But if you look at weight, there's much difference in people's weight. So weight very much. So when you, let's say you plot the two and you do the normal distribution for them, the type of bulginess will be, the spread will affect the bulginess. And that is why the normal distribution on its own is just like a crude. Intelligent people now came. Okay, why can't we? Okay, another thing I didn't say, just remember, apart from the fact that normal distribution, the bilaterally symmetrical, is one side of better way or the other. Then I think it's bell shape. Mean, mode, and median is the same. What it means is that as we have found out that the most frequent one is the one that the middle one, sorry. As we have demonstrated that there's a middle value. Then if you arrange, when you arrange those values in ascending order, the middle value, if you have, you get a middle value. If you, that particular middle value, if you say which one, the frequency had the highest frequency, which is what we have demonstrated here. For example, in the example we gave, say 70 have the highest frequency because that's the peak of the graph. That's the highest frequency. That middle value will be the one, the value, if it's 70. If you arrange in ascending order, that 70 will be the one in the middle. And that 70 is the one that moves. So you can have a lot of 70, but the one that will be in the middle will be part of that 70. Now, if you add all the value together and calculate the average, that 70 will be the mean. So in that situation, in a normally distributed variable, mean, mode, median will be the same. So I think that's what many people know. In normal distribution, mean, mode, and median the same. Now, let me come back to what. So intelligent people now came with an idea. They now say, what should we do? They now go with instead of measuring, because deviation, when we talk about because we have already said it's because of variability, the way the things spread, it's because of that variability that make it not to, for all the variable variability based on the scale you use to measure it. So intelligent people now come with an idea. Instead of we expressing variable, the score of each person, like for weight now, in your weight, we now use the number of standard deviation away from the mean. Let me explain. Let's assume that these ladies that are posting for picture, they belong to one club. that where they do exercise to reduce weight. And these people, they have different weight, these 5 people that post. And let's assume that maybe there are about 1,500 people that are in that club that are involved, that are registered there. Let's say the average weight of these people is 70 kg. It's an hypothetical value. Average weight is 70 kg. And the standard deviation is 10. No, we have already talked about standard deviation and mean. The mean is 70, the standard deviation is 10. Now, 10 kg. We know that the mean and standard deviation, they are on the same scale. But if it is a variance now, it will be square, the scale will be kg square. Because in trying to calculate variance, you have already squared something. But of course, when you finish calculating variance, you calculate the first square root. That's why you remove that square. That's why you quote standard deviation, mean plus or minus standard deviation, not mean plus or minus variance. Because variance does not have the same scale as mean. The scale of variance is square. That's why the one for the mean is not square. So for you to get back to the scale of the mean, you calculate, you square root of that variance and give you standard deviation. So 70 kg, 10 kg, 70 kg mean average, then 10 kg standard deviation. So let's assume that this first lady you see measure 50 kg. That's the weight. So Z is the number of standard deviation away. You now say, okay, 50 deviation from the mean will be 50 minus 17 because it's the mean you remove from the value. Look at the formula. Z is equal to X minus mu. Mu is the mean in the population. Rho is the standard deviation. So X is the value of each of them. So if you now say 50 minus mean, 70. Who is some, please, let's mute ourselves. So when we say 50 minus 70 now, you now divide, if it's 50 minus 70 is 20, it's minus 20. Let me locate the person that is solving now. Is Dr. Nonju. Don't let us dissolve the class. Now, 50 minus 70, it will give you minus 20. Divided by 10, it give you minus 2. The second person, you remove 70 from 60, it give you minus 10. Divided by 10, give you minus 1. The third person is weighing 70, which is equal to the mean. 70 minus 70 is 0. It's 0 over it is 0. Then the other person, fourth person, weigh 80. 80 minus 70 give you 10. Divided by 10 give you 1. Why 90? 90 minus 70 give you 20. Divided by 10 give you 2. So can you see? You divide the deviation from the mean by the standard deviation to know the number of standard deviation away from the mean. For example, now, if you say somebody, the mean is 17, the person that is 16 is like one standard deviation, 10 kilogram to the left of 60, that is 70, that is 10 kilogram less than 70. The person that is weighing 80 is 10 kilogram higher than 70. Now, it's just like you stand somewhere, you stretch your hand, is 1 meter. Somebody is 1 meter to the right, another woman is 1 meter to the left. Both of them, they are equidistant from you, but in different directions. It's the same thing. The person that is 90 kg is 20 more than 70. That is on the right side. While the person that is 50 kg is 20 less than 70. So both of them, 19 and 50, are equidistant from 70, but in opposite direction. The way 80 and 60 are equidistant from 70, but in opposite direction. So that is why you see 10, 10, 20, 20. But this other one will minus 10, minus 20, while this one is plus 10, plus 10. But when you divide by 10, which is the standard deviation is 10. When you divide 10, 20, all those ones by 10, it gives you 2, 1. So, but that's why you now see the number of standard deviation away from the mean is minus 2, minus 1, 0, 1, 2. Now, you see that those ones that are less than the mean, they give you standard deviation negative. Those ones that are more than the mean give you standard deviation positive. The ones that are equal to the mean give you 0. So that Z, which is the number of standard deviation away from the mean, called Z-score. So if for every variable you are dealing with, if you can do that, calculate the Z-score, you don't need to put the unit. It's dimensional. It's a ratio. You remember we say ratio is when you divide two quantities of the same unit. So if you look at it, when you say 50 minus 70, we give you minus 20. It's minus 20 kg. Over 10 kg, kg cost cancel kg. So what you have is minus 2. The same thing with all of them. So it's not minus 2 kg or 1 kg. No, it's minus, they are ratio because the unit are cancelled out. So it's dimensionless. It's a standard. It's a standardized thing. So it's the same thing, whether you are in engineering field or medicine or market, commercial or whatever, or art or anything, anywhere you are doing it, is the same. So you have cancelled the effect of that unit from variable. So instead of now, when you want to plot normal distribution, you will not, instead of you plotting with kg for weight, centimeter for or meter for height, kilometer for distance, no, you plot with the Z-score, which is number of standard deviation away from the mean. When you plot it now, it gives you this graph, which is what we call standard normal distribution. So the normal distribution you plotted with the Z-score is standard normal distribution. It's only one in the universe. It's only one. So whereas for normal distribution itself, each variable has its own normal distribution. Any variable that follows normal distribution has its own normal distribution. But there's only one standard normal distribution. That is when you have converted those values into Z-score. So you now plot this one. It's only one. It's universal. So, and the area under this graph is 1. And the mean is 0. So if let's say we have lots of that, I will be asked you, I will ask you if it's workshop now. No, I will ask you, okay, how is the mean equal? You should be able to prove it from what we have discussed now. Why is the mean 0? How is the mean 0? Why should the area be 1? So maybe somebody want to tell us. The area under this graph is 1. And you know 1 means 100%. 1 means 100%. I'm trying to give you the logic. So who can let's just say it's the lecture, so we can discuss. Somebody can unmute and say, okay, why is the mean equal? Why is the mean 0? From what we have done, you will be able to know that the mean is 0 for standard normal distribution. Why is the mean 0? Nobody. Okay. If you want to talk, you have to unmute. If you don't unmute, we will not hear you. So why is the mean 0?
Is it because it's a sum total of the standard deviation on both sides? So it comes to 0, isn't it? The negative.
Well, that's a very good logic.
That's, sir.
But even I'm showing you the picture now. Look at this picture. Why is it mean 0?
Because 70 minus 70 is divided by standard deviation.
You know that when you convert from the normal scale to the Z-score, the mean, when the mean, any value that is equal to the mean, the Z-score will be 0. And the mean is the one in the middle. So that's why in the standard normal curve, the mean is in the middle. The mean is 0. That one in the middle is the mean. And you already, well, you are right anyway, because to this side, because if you remember, when we do, I think we are discussing, when we're talking about descriptive statistics, when we're talking about deviation from the mean, x minus x bar. So if you arrange it in ascending order, the initial one will be less than mean. When you remove mean from them, they will be negative. The one that are equal to mean, will remove mean, it will be 0. Those ones that are more than the mean, as you are removing the mean, they will give you positive. But if you try to add them together, to cancel out, because the mean is in the middle. As much that are positive and negative, when you add everything together, you get 0. And that is why they now square before they can do any further statistical analysis. That's why they square. Because you know that by adding those things, it makes no sense. But when you square something that's negative, you remove the negativity. Are you see now? So you are partially right, but the explanation is that the mean is in the middle. Now, why is the area equal to 1? Area under the graph, why is it equal to 1? Cannot say that. Okay, the area, okay. If you are, it's very logic. We say this is bilaterally symmetrical. So when you cut the graph in the middle, one side is the equal image of the other. So if you, that line in the middle, I divide it into 2. One is half, the other one is half. Half plus half is what? Is 1. It's just a logic. When you buy a loaf of bread, that loaf of bread, irrespective of the size, is 1. It's 1 loaf. Then you now want to, you have twins. You say you want to cut it equally for them. You now cut it in the middle. You give half to this, give half to this. If you are, there are 4 people you want to give them equally, you first of all cut it to the middle. Then later you cut the half into the middle also. Their own middle. It gives you 4 equal. But those 4 equal is 1 over 4, 1 over 4, quarter in 4 places, give you 1. Does it make sense now? It's just logic. Some of those things, they are logic. It means equal to 1. The area is just 1. No? And 1 means 100%. Now, that is not all. It has been proven by intelligent people over and over. Apart from the fact that this normal distribution, there's a standard normal distribution. Though standard normal distribution just make it easier. It's the same thing, it's actually applicable to normal distribution. But of course, for you to conceptualize, we talk about this standard normal distribution. Now, the intelligent people, they have discovered that in between the value that corresponds with -1 standard deviation and +1 standard deviation, when you have your sample like this, so the people that have value that correspond between -1 and +1 standard deviation, they are 68.27% of the sample. Or if you are talking of the whole population, 68.27% of the population have the value in between -1 and +1. For example, the example we give here now, the value that corresponds with -1 is 60 kg. The one that corresponds with +1 standard deviation is 80 kg. What is telling us that among these people now, 68.27% of them, or the population of these people that are doing this exercise, they are in this club. 68.27% of them, we have value in between 60 kg and 80 kg. Because those are the values that correspond with -1 standard deviation and +1 standard deviation. So they also find out that in between -2, that is 95.45% of the observation, we have value that correspond with -2 standard deviation, between -2 standard deviation and +2 standard deviation. So in our example now, the value that corresponds with -2 standard deviation is 50, +2 is 90. So what is telling us is that 95.45% of these people will have value between 50 kg and 90 kg. So go for that. Is it in between -3 standard deviation and 3 standard +3 standard deviation, 99.73% will have value in between. That's almost all, of course. In our example here now, what value corresponds to -3 standard deviation? I want to see if you are following. What value corresponds to -3 standard deviation? You can unmute and answer. If you are muted,
corresponds to -3 standard deviation.
Yes.
That would be 99 point something.
No, what value, what kg, how many kg correspond with -3 standard deviation? Among these.
That would be 100 minus 100 minus 70.
90 kg.
40 kilograms.
40
So
40
kilograms.
less than
100.
50,
Yes.
less than 50
10
and
minutes.
100.
Look at 10 value. You know the standard deviation is 10. Look at it, from 70, we have 60, 50. So the next one will be 40. Will be 40 kg. What of 3 standard deviation? What value corresponds with 3 standard deviation?
100.
100. 100. Because when you add 10 to 90, it gives you 100. So it shows that some people are following, some people are not following. Please ask question. Because some of these things, they look tricky, they are like logic, but that is the basic. When you don't understand them, so when you are now faced with real life, you will say this statistic is because yes, somebody has said it, 40 to 10 kg. So somebody chatted and give the answer. So there's nothing big deal about. I've already told you before. It's secret. If you know statistics very well, you know the secret. That just it. Not that you are more brilliant, more intelligent than the rest. No. Because there are a lot of people that are very intelligent, they don't understand. It's because they don't know the secret. That is why the statistics like mathematics, the people that know, they know it very well. They look like genius. Why the people that don't like it? No, they don't want to talk about it. Not because they are not intelligent, because they don't know the secret and they have not found time to learn the secret. And once you learn the secret, you will be looking at you as if you are a superstar. Nothing like that. It's a secret. So, and that is, I'm trying to let you know the secret. Now, let's now look at it. The intelligent people, the researcher, they are not interested in 95.45. They are now in, the area, total area under the graph 100. So they are interested in the middle 95. So they are looking for something that, what standard deviation? We know that -2 to -2 to +2, it captured the middle 95.45. If you remove that 0.45 from it, let's look at the middle 95. What standard deviation will correspond with it? It was found that it's 1.96. So between -1.96 to +1.96 standard deviation, 95% like the middle 95%. So we are now left with 5%, 2.5 on the left, 2.5 on the right. So 95% of the observation of the people, they capture the attribute, that value that lie in between -1.96 and +1.96. And that is the origin of 1.96 you see when you are calculating sample size. It says Z is standard number deviation that corresponds with the level of significance. I'm going to tell you why it's a level of significance. Because they believe that for normal people, that is normal, that's the origin of normal, normal value or whatever, reference range, reference value. Between the 95% of people in the middle, the extreme 5%, they believe that it's either is extremely low or extremely high. They are abnormal. So if these people, they are interested in the middle, they are middle 95, they are 1.96. Then the remaining 5%, that is what we call significant. So any value outside is outside the range of normal. We are seeing it, but before you can understand that normal distribution as a basis for hypothesis testing, we see to discuss inferential statistics. You get to understand it very well. But this was just to whet your appetite on it. So when you are calculating samples, I say 1.96, Z will correspond with level of significance. Because it's the same 95% when we talk about confidence level, 95. So the confidence level plus significant level add up to 100. The remaining 5% is the significant. The middle 95 is the confidence. So making you had, if you say your study, the level of significance is set at 5%, 0.05. That shows that your level of confidence is 95%. If you choose 0.01, your level of confidence is 99.1. 99.9 rather than 99.9%. So now let's look at this. We want to break our brain now. You know, I told you before, I said that this normal distribution is an example of a continuous probability distribution. This continuous probability distribution now, I told you that you cannot know the probability of a given value. That one can be known if it is discrete probability distribution. But for continuous probability distribution, you can only know the probability of a range of value, less than, greater than, or between this and this. Now, and that is why before you can make anything meaningful out of continuous probability distribution, you have to plot the graph. And this graph is what's called probability density function. You know, we have already said before, the probability distribution is a theoretical one. You can represent by a table. The statistical table you see is a table of probability distribution for all those statistics. You can use graph. You can use equation. Look at that guy. You put the equation of normal distribution there. And that one very difficult to just begin to calculate. But the graph give you picture. So when you represent this graph, is what we call probability density function. So you can actually calculate the probability using this graph of a range of value. For example, now this graph I'm showing you now. You know there are two graphs here. We have the one up, the one down. The one up is the normal distribution for systolic blood pressure for a population. The normal distribution of a systolic blood pressure. While the one below is the corresponding standard normal distribution when you plot it using the z-score. Are you seeing that? They just overlap so that you can see the relationship. Now, if I want to ask you now, if the one up is the normal distribution, the one down is the standard normal distribution for the same thing. So what is the mean systolic blood pressure? So you have to be answered now. Answer. It's not me that will tell you. Almost I be you to answer. What is the mean systolic blood pressure?
100.
100.
Thank you. Yes, 100. Dr. Ganil. Cut your 100. Now, what is the standard deviation?
Of what? 0.
The standard deviation of systolic that systolic blood pressure now. The mean is 100. What is the standard deviation?
0.
0.
It's not 0. You say the mean is 100. How can the standard deviation be 0?
Oh, okay.
The standard deviation of the systolic blood pressure.
16.
You say the mean is 100.
16.
It's 84 and 116.
It's 16. It's 16.
16. It's 16. If you look at the graph, we have already said that.
84
Look at this.
and 116.
What do you say?
84 and 116.
It's not 84. The standard deviation is 16. It's 16. It's 16. It's 16 because we have already, if you look at the standard normal distribution down,
Okay.
we know that the mean corresponds to that 0. One standard deviation, we have already said that. This one standard deviation, this one is one standard deviation. So if you look at the mean, which is 100, corresponds with that 0. That one standard deviation, now that is the value of the standard deviation. Now, when you now between 100 and 116, what is the difference?
16.
16. Between 100 and 84, what is the difference?
16.
16. So it shows you that the standard deviation is 16. Now, to confirm it further, you know, normally, if it's a 2 standard deviation now, we give you, if it's 2 standard deviation, we have mark here now. Maybe it's 2 standard deviation, the right here. This one should be 68, this one should be 132. But because it's not up to 2 standard deviation, it's almost 2, which is 1.96. That's why when you have 16 plus 16 here, it will give you 132, but it give you 131 because this one is not up to 1.9 is not up to 2 standard deviation. The same thing on this side. So if you remove 60 from 84, it will give you 68. But because it's not up to 2 standard deviation, that's why it gives you that 69. Does it make sense? Now, yeah, it makes sense. Now, what is the probability that somebody has blood pressure 100?
50 or 0.5.
Say somebody has systolic blood pressure 100 millimeter of mercury.
0.5 is mid.
So that's final answer. So you cannot calculate it. You have already told you that it's not possible to calculate the probability of a given value for continuous.
Okay.
So I just want to answer. Okay, but we can calculate the probability of a range of value less than, greater than, in between this and this. Okay, what is the probability that somebody has blood pressure less than 100?
0.5.
Thank you, 0.5. You're right, because that 100 is the one that corresponds with the middle. So it's 0.5. Greater than 100, so it's 0.5. Okay, what's the probability that somebody has blood pressure, systolic blood pressure between 84 and 116?
0.25.
Eh?
0.25.
Between
Why not 0.5?
It's 1 quarter.
Somebody, what is the probability that listen, let me tell you something. That probability you are measuring, you know, the total area is 100. Is the proportion of the area you cover that is the probability. Maybe I should explain that. For example, when Dr. Ngozi said that probability of having blood pressure less than 100 is 50%, because we know that the area is 100%. And this is bilateral. This side, the middle to this side.
That means 25, sir.
What do you say?
25.
No. The probability that somebody has blood pressure between 84 and 116.
No, okay, it's not possible. It's 1 quarter, sir.
Which 1 quarter?
Why not 0.5?
0.5, sir.
What's your question again, sir?
What is the probability that somebody has blood pressure between 84, systolic blood pressure between 84 and 116?
It's 50. It's 0.5.
0.5.
When you say that
0.5.
less than, listen to me, less than 100, somebody has blood pressure less than 100 is 50%. It's 0.5. Why should it between 84 and 116 be 50%?
Okay, we say
there's 0.25 on either side of 100.
Okay, let's resolve it. So what did I say? In between minus 1 standard deviation and 1 is 68.27. So the probability is 68.27% or is 0.68. In between minus 1 and plus 1 standard deviation. 84 corresponds with minus 1 standard deviation. 116 corresponds with plus 1 standard deviation. So the probability is 0.68. This question I asked my student, final year public health student. That's why the question I said for them. No, I didn't know. No, I did the one. No. I think it's 200 level set. Statistics, 200 level I set it for. To calculate it. Of course, I taught them. I didn't see them. So, does it make sense now? So yes, what's the probability that somebody has blood pressure between 69 and 131?
69 and 131.
That's 95.
That's 95.
95.
Okay, what's the probability that somebody has blood pressure above 135?
131, you mean?
0.25.
0.25, yes. 0.25. Yes, you're correct. Less than 69 also 0.25. Okay, what of greater than 116?
Greater than 116 is
0.2. 0.5.
No,
No,
how can it
no.
be 0.5? So, okay, how will you do it? How will you calculate it? You may not be, how will you calculate it?
0.68.
You know that, look, you want to know greater than 116. You know that in between 100, you know, greater than 100 is 50, 0.5.
Yes.
In between 100 and 116 is half of 68, which is 0.32, 32%. Remove that 32% from 50%, it will give you the probability that it's greater than 116. Does it make sense?
Yes.
So
Yes.
they may not, okay, what is the probability that somebody has blood pressure between 69 and 116? Can you see now?
That's
That would be
How will you
99
do it?
divided by 2 minus 33.2. That's 0.3. The probability of having 131 is 99.
No. I say I want, well, okay, 931, 99.
Then
No,
the
you cannot say
having
probability of 131. You can only have
only
probability for a range of value greater than or between this and this. You cannot just pick a value and say you are calculating the probability. I've already told you. For continuous probability distribution, you can only know the probability of range of value greater than or equal to or between this and this. So I'm asking you between 69 and 116, what's the probability?
You have to go back to the format.
It's very simple now. Look at it. You know, listen. You know that from 69 to 131 is 95. Is that not so?
95, yes.
And the half of it is between 69 and 100. Abi? Half of 95 will be 40 what? 47.5, right?
Yes.
Yes. So you know that between 84 and 116 is 68. Half of it is 32. So that 47 plus 45 plus 32 will give you the value from 69 to 116. So you get the half of 69 to 131 and add it to half of 84 to 116. It gives you what we are saying. So you can actually say, what is that? It's very simple.
Yes, sir.
You know that you are looking at area between 169 to 116.
Yes,
and you can break into two. 69 to 100 is half of 69 to 131.
Yes.
You know the 69 to 131 is 95. Half of it will be from 69 to 100. The half of it will be 47.5. You know that between 100 and 116 that remain is half of 84 to 116. 84 to 116 is 68. You divide by 2, make it 34 rather. So just add 47.5 plus 34, it gives you what we are talking about. So different way of concept. Once you understand the concept, you don't have problem. Are we together? So now we talk about this skewness the other time. So if anything, when I've already explained what causes skewness, if it's not normally distributed, it's not bilaterally symmetrical. Look at these two now; they are not bilaterally symmetrical. One half is not the mirror image of the other. So this one is skewed to the left, negative skewness. And it's because there are some outlier that is extremely smaller than the rest. In that situation, you see if you know where from measurement you are starting from origin, as the value increase, if it is weight as it's increasing like this. So mean is smaller than the median before the mode. The mode is one at the peak. So when you have an outlier, you have a value that is extremely smaller than it jacked down the mean. It made the mean to be small than what it should have been. But if it's an outlier, positive outlier that is extremely bigger than the rest, it jack up the mean. When you are moving along the continuum like this, you get to the mode first before median or mean will be the highest. That's just. It's just trying to explain it. So I think I'll talk about kurtosis and orthotics and skillness. So the next one now, I think we are talking about, we have finished talking, yes, that's the end of probability distribution. Just to summarize, that's something that I don't need to explain here. I think we have finished it in 2 lectures now. In the next lecture, that we'll be talking about introduction to inferential statistics. Any question? Any question?
Next lecture will be introduction to inferential. So what we have been doing is summary statistics, or what have we been doing?
We have just finished probability and normal distribution. We talk about, we say statistics divided into descriptive and inferential. We also talk about the relationship between descriptive and inferential statistics, the probability. So you cannot separate probability from statistics. It's actually part of it.
So what we have been doing, doing is descriptive statistics.
Well, yes, we have discussed descriptive up to the last 3 lectures. In the last 2 lectures, we just talk about probability. So in the next lecture, I will not talk about inferential statistics, introduction to it, so that that is what will open our discussion to all those chi-square, all those apposite tests, which are fully inferential statistics, all those t-tests, all those form of their confidence interval. We talk about confidence interval and apposite testing. Okay. So the next thing now is to talk about introduction to inferential statistics. There we talk about apposite testing and confidence interval. The issue of p-value, all those, we talk about them before we now go fully to discuss those inferential statistics. Who is this person that is using Yahoo? Who is this one? And that person chatted, though. Please, who is this person? Before you using your name, we can identify you. Who is this person? GDGZ. Okay, but that person, I will remove you if I don't. Let us identify you. Okay, ask your question, Dr. Moses.
Please, can you bring up the slide where you have the z-score illustration or something like that? I just want to show you something.
Yeah. This
no,
one.
So now we have, you're talking about mean, talking about standard deviation here, and the way then you now say Z. You now
Z is Z, what I call
then you now
Z.
say number of standard deviation. Where does the Z, what's the Z score here now? That like is the Z score? I don't know how to put it. What I'm trying to say
is score actually is this score is the same thing, number of standard deviation away from the mean. Is it no minus 2, minus 2, minus 1, 0, 1, 2. Those are the Z scores.
That is what a Z score is. Okay.
Yes.
All right. So I was wondering where the Z score fell into all this. Okay. All right. Thank you.
And that's what you now use to plot this one.
Yes. Okay. Okay. All right.
Okay. Any other question? Somebody chatted. Yeah. Professor Prof said something. Well, the Prof is saying that when it comes to pay workshop, it keep one engaged. But you know the issue, even we can even do workshop without. I did workshop for some people, they are not serious about it. I did workshop where they run with experts